Now we'll start with simulation of rectifiers and regulators using LT-Spice. Okay, let me take the source. Unfortunately, we don't have a transformer, so let me take the secondary voltage of the transformer, which we want to have it as 9 volt RMS. What is 9 volt RMS corresponds to peak of?
9√2.
How much is that, man? Give me the absolute value. Okay, take the value of here.
12.7.
Okay, what I'll do is I'll make this as 12.7. No, this is not 12.7. Let me just go here, go to advanced, go to this sign, let the offset voltage be 0 here, and then 12.7. 12.7, and then let the frequency be 50 hertz. So we will also discuss some of the questions what people have raised. Okay, in that. Okay, all these things fine. Okay, delay all those things. Even if you don't edit, okay, it'll take the default values. This is that now. Next, I will make the connection of the rectifier. I think some of you might have practiced and some of you are yet to practice. Let me see when you people finish off. And I need to have a ground here. So this is again F3. We'll connect it. I will make this equal to 1K. This is done. Since I want to see the time response, I have to do dot tran, that is transient response. Let that time period, if you want to see around 5 cycles, because 50 hertz corresponds to 20 millisecond in time for 1 cycle. If you want to see around 3 cycles, let me just make it 60 millisecond, and let the starting should be 0. We take it as 1 micro. Okay, this is my time, so that I can see 3 cycles with a frequency of 50 hertz. 50 hertz corresponds to 20 millisecond, so 60 millisecond corresponds to 3 cycles. Let me run it now. I think I can now run. This is the input waveform. Sine wave, you can see 1, 2, 3 cycles. So I will take out this also. Okay, I hope this is fine, and we will see the output waveform. Let me change the color of this. Okay, let me make this red. Ayush, is this visible?
Yes, sir.
Okay, can you see this is input voltage green one, output is what, red. If you carefully observe this, if you carefully zoom it and see, can you see the input voltage is until it is 0.7, it is not turning on. Can you make out that?
Yes. Yes, sir.
So see here, so till it is some voltage, red is still 0. So at each and every point you have the red lower than the green one, meaning that output voltage is always less than the input by the diode drop. Correct?
Yes, sir.
So this is your rectified waveform. So I can again make this so and so. So what I'll do, I'll put a capacitor. I'll put a capacitor to do this. So if at all, if anybody has any question, can just ask me now. So one of the question was, so we have a different transistor. You can pick a diode here. So one of the diode can be 1N914. So I can select this. You can run it. See what happens. What is this diode? Suppose you can see I can either select that or this. There are different. Now for this also it almost looks like the same. It almost looks like the same. So if you want to know exactly what it is, you can see each and every device will going to have some model parameters. If you can see, is this visible?
Yes, sir.
Can you see 1N44148 is a silicon type, and you can see its breakdown voltage is 75 volt. The I average is this is the average current is 200.2 amperes. You can see the model specification. IS stands for the leakage current, RS stands for the on resistance. Okay, this N is maybe some device parameter, so it's not of important now. You can see now something here. Where is this? Okay, type silicon type. You can also see xenon diode is there. So this is pertaining to specifications of the devices, you can also see there are some capacitances. Junction capacitance is 4 picofarad. This is 4 picofarad. If you want to still have a larger capacitance, you can see there is a 190 picofarad capacitor, which is a Schottky diode, which is if you want to have this type of junction capacitance, then you have to select this. So for this particular rectifier connection, for rectifier operation, you can select any diode. You can select any diode. So what I'll do is I will put a capacitor. Okay, let this be 1N4148. Is there any
Sir, there's a
questions?
doubt, sir.
Yeah.
Sir, in the video, sir, you had told that if we'll put a voltage of 6.2 volt, then at 5 volt, when we add the capacitor
Mm.
uh, for load regulation, sir.
Okay,
Sir, if we
let me come to that.
okay,
Let me come to
okay,
that. So I'm just in the first phase of my rectification. So this is purely rectifier. I'll certainly
okay,
answer those things. Okay, let me just go to filter now. So how do I get the filter? I'll add a capacitor. So we'll clear all your doubts. Okay, now this is done. Okay, now let me put a capacitor of how much value shall I put? Can somebody tell?
100 micro, sir.
100 U. Okay, now this is 100 microfarads on, so you can see, run it now. See how it happens. Only for the initial cycle it charges, and then it goes to maximum. It's coming down. It's again. You can see this is your discharge period. Here diode is off. Suppose if you want to see whether diode is off or on, how do you make out that? Sorry. How do you make out whether the diode is on or off? Oh.
So when
Let me see
so
the current through
when
this. Let me see the current through this one. Can you see here? Diode is on only during this period. You can see during this entire period,
and
diode is off.
yes, so when it is charging, the capacitor is charging, then the
They,
diode is on.
then only diode is on. So that's perfect. So let me just show you that. Can you see here? When it is charging, then only the current is there. Otherwise, current is zero. When current is zero means the capacitor is discharging through resistor R. See here?
Yes,
When the capacitor is charging, then only the diode is on. When the capacitor is discharging, it is through resistor. This is off. Is that clear here?
yes, sir.
When it is charging, then only there is some current. Whenever it is discharging, current is fully zero. Done? Perfect. Now let me just take out this current unnecessarily, which is there here. I have removed it. Now we can certainly measure the ripple voltage. So shall we measure the ripple voltage? So I'll just keep
Yes,
one at the top, one at the bottom of this ripple voltage. How much is that difference? Can you see the difference?
1.5 volts.
Any difference is vertical difference is this
1.95.
1.95. Of course, you can certainly verify theoretically how much you'll get it. So how much will be the theoretical difference you're supposed to get? Uh, because we know the expression for what is that? What is the expression for the ripple voltage for a half-wave rectifier? Is it Vp minus Vd on? This
VD
is
on
V
by
ripple
FRC.
FRC.
Yes,
How much is Vp minus Vd on here? This itself is Vp minus Vd on. That is it 11.96?
yes, sir.
Is it 11.96 is Vp minus Vd on divided by
Yes, sir.
F is 50 into R is 1K. How much is C? 100 micro. Correct?
Yes, sir.
Hello?
Six.
Correct? How much is this value? Give me quickly.
239.2.
2?
39.2.
239.2 millivolt. Am I correct? Let me just find out. 11.96 divided by 50 into 1 exponential.
It's 2.39.
Okay,
It's 2.3.
100 exponential minus 6. It is 2.39 volt. Correct?
Yes, sir.
But you can see theoretically in simulation wise how much you're getting. You're getting 1.9. Correct?
Yes, sir.
You're getting 1.9 volt. So why do you think there is a difference between the actual theoretical value and the actual value? So there is a difference. There is certainly a difference between the expected value and the actual value. I think you may be, of course, sure that okay, when we actually derive the expression for the ripple voltage, we have assumed some what is that assumptions. Can you see here? These are the assumptions. We assume
Yes,
that
sir.
okay, this T2 is almost equal to T3. All those things, correct?
Yes, sir.
Because of these assumptions, we have slight error of instead of getting 2.39 as a theoretical calculation, you're getting 1.9. Correct?
Yes.
So you have to appreciate or you have to know why there is a difference. The difference is because of this approximation, because here this T2 is not exactly equal to T3. And we also wrote that okay, this is not V ripple is not exactly equal to, but it is approximately equal to V ripple. Am I correct?
Yes, sir.
Okay. Is there any questions here to anyone?
It is not a slight difference. It is a difference of 0.5.
It's fine. Okay, you're not too much worried about okay how much is this. Suppose you want to reduce it, because that purely depends on how much is this error is. Suppose if this error is, now we can see, suppose if I increase the capacitance value, now we can just see the difference is how much. It's almost 0.4. I'll just do one more simulation, then let me know you okay what will be the error. So what I'll do, I'll just go back to this circuit and then I'll make it 1000. You see, I'll make it 1000 U, and now tell me what will be the error. Now what I'll do, now error will be a bit less.
Yes, sir. 239 millivolts
No, 239
is
millivolt.
the theoretical value.
Let us see what will be the what is the actual voltage that you're getting. So I will place both the cursors, one at the top, one at the top of this, and other at. How much voltage? How much you want?
181, 239.
239. Now this much voltage is fine. So don't too much worry about, again, we're not exactly looking for that voltage, because there are still some approximations. There are still some approximations, and because of which you have this small error. This is not a big error in terms of okay voltages when you are dealing with rectifiers and regulators. This is fairly okay. This is not, don't go like okay, in mathematics if it is 2.5 is not equal to 2.3, in mathematics wise it is not equal to, but here in electronics when you're designing something, this much approximation is allowed, especially for this rectifier circuit, because you're not too much worried about okay, if the ripple is 500 millivolt more, there's not a big harm on your circuit. Is that okay?
Okay, sir.
Okay, now
Yes,
Sir,
sir.
when we actually increase the capacitance size, the
mhm.
time lag will increase, right, sir?
What time
The
lag?
time period. I mean, to the peak, it will come down. Discharge time will be more, right?
Discharge time will be more. The error will slightly reduce, because then now T2 is almost equal to T3. You can see the different, the separation whatever we had. Where is that? Here. This separation, because it is not discharging too much. This T2 T3 comes very close to each other.
Yes, sir.
There are other issues with going for very large capacitance. We need to have a balance between what is the typical value of capacitance. It will be around 1000 microfarad to 500 microfarad. So that's the typical range of value of C that will be connecting. Correct?
So, but the lesser ripple we get, the good is value, right?
Good is the
We should get.
value. Okay, okay. In that case, we cannot go for 10,000 microfarad as a capacitance value, because the capacitance size will become more, and the cost of your the filter design will be more. We need to keep that also in mind. Okay.
Yes, sir.
We'll just go back to this and then let us put a regulator. So where is the regulator? Regulator is here. I will go to, okay, regulator is there in this, okay, power products. See here, just go to each one of them. Can you see this is a regulator of 5 volt, 3.3 volts. If you want to have 5 volt regulator. See here, of course you have to spend some time with these libraries. In power products you have these regulators. Go to each one of them. There are different power components available, in which I am looking for my regulator, because I know that 7805, 7905 are not available. I'm just looking for a similar type of regulator. Can you see here? It is 5 ampere, low dropout, positive regulator, fixed 5 volt output. So it will give a fixed 5 volt output. I'll connect it here. Any doubt here?
No, sir.
Okay, I will connect this output to this, and then ground to this, and this is my output. I will connect this here. I will label it as Vout. Correct? This
Yes,
is
sir.
Vout. I'll put it here. This is F3. I will label this and then connect it. I will run it now. Okay, let me go back here and then try to measure this also. Let me measure. Can you see now the output voltage is constant at
5 volt. Yes.
can you see it's 5 volt?
Yes, sir.
Can somebody say what is the minimum voltage that is required to get exact 5 volt?
So 6.2.
6.2 is my assumption in my calculation. 6.2 need not be 6.2 here. So that we can actually find out here. How do you find out is you run a what? Can I just move it on the red line? I'll just zoom this. I'll just move it on the. What is this red one actually? Is the red is the input for your regulator? I'll just go back here. I will name this as okay, F4. F4 is V into regulator, correct?
Yes.
V in REG. There's no space allowed. Okay, now F3. I will, sorry, not F3, F5. I will cut this. Now I'll rerun it. Okay. Can you see the red one corresponds to input to the regulator and the green one is output of the regulator?
Yes, sir.
Shall I just take one cursor on this input of the cursor? Can you see after this input voltage, does the output become 5?
Yes, sir.
Now, according to this plot now, what is the minimum voltage to keep at the input of regulator so that you get exactly 5?
6 volts, sir.
5.9.
5.97. It should be more than 5.97 volts, correct?
Yes,
If
sir.
the input voltage to the regulator, if it is more than 5.97, that is 6 volts, then only you will get a constant 5 volt. Otherwise you are in trouble. What do you mean by trouble? The output voltage
Constant.
will not be constant at whatever regulated voltage of 5 volts. It will be, of course, pulsating. Correct?
Yes.
So what I'll do, I'll just go back to this. So did each one of you got, okay, suppose if I make this equal to somewhere around 7, what might can happen? May not be 7. Let me make this. Okay. Is this giving a regulated output voltage? Green one?
No, sir.
You can see it is there stable or till this point only. Can you see it is almost stable? Can you see it is less here?
Yes, sir.
Why it is less? Because the input is less than 5.9.
Yes, sir.
Why it is less than 5.9? Because your input from your transformer itself is less. So I had to go back to I think I have some issues with Ayush. Ayush, can you mute yourself? I just want someone to. A lot of background noise is there. Can somebody unmute? Okay, where I'm now. Okay, I want this. Okay. So how do we overcome that? We can overcome that by just going for a larger amplitude. So I can make the amplitude as around 10 volt. It's fine. 10 even, of course, how much was that? It would have been
12.5.
12.5 corresponds to 9 volt RMS. That's it. Okay, now let me run it. Somebody was asking some question on regulator. Can I know what the question? Someone, I don't know who is that person.
So, I
Uh,
was asking that you
uh,
had taken the assumption that if we'll put 6.2 ohms, below 6.2 ohms, there will be, sorry, volts, sir.
Okay.
Below 6.2 volts, there will be, it will not be constant, sir.
That
Why 6.2 volts, sir? Is it because of the voltage that we lose in diode, or is it
see
something else?
here. This is an IC, correct?
Yes,
This is an IC which has some. Suppose if you just go to the specification of this, can you see here? Okay, let me just stop this, and if I can just go to that, where is that, here there was something like, I'll just explain that. So it is F2. I'll go to F2. Can you just see here? Can you just read that? 5 ampere low dropout voltage regulator. You can see
yes,
here,
sir.
this is low dropout. See here, what is this low dropout is, because when you are applying some voltage to this at the input of a regulator, it is necessary that this regulator should not consume too much of voltage, meaning
Yes, sir.
the input voltage that is required at the input to get a regulated voltage should not be too much greater than what is regulated. Assume that if you want to get 5 volt, it is not required that you have to apply something like 10 volt. So if you are applying 10 volt, if it is giving 5 volt, means okay, it is consuming too much of voltage. So then I cannot call it as low dropout. So when I say low dropout, because they are coming in series, no? Is it not
Yes,
coming in series?
yes,
When
sir.
they are
Yes.
coming in series, it will certainly consume some voltage. As
Okay,
this
sir.
IC requires some voltage to give the constant output voltage of 5 volt, it requires minimum 5.97 as per the data sheet of LT1084. Correct?
Yes, sir.
It is not due to this part of the circuit. Whatever 6.2, what I have assumed, it is not due to this part of the circuit, which is the rectifier filter. It is due to the operation, the internal operation of this particular IC. So this IC says that I require around 0.9 to give a proper output voltage. So you give it as more than 0.9 volt than the required one. Okay, what we'll do is we'll just change it to some other IC. So what is that IC? I'll take it as maybe this. What is this? This you can see, this is
It's a
a
low dropout, sir.
12 volt.
Yes, sir.
It's a 12 volt. You can see the current is only 3 amperes. The previous one was 5 ampere.
Yes, sir.
This is 5 ampere. Now this is 3 ampere. What I'll do, I'll take this and I will delete this. Now I'll put this now. I'll just take out F7, put this here. Can somebody say what will happen if I run this? Will I get 12 volt constant?
No, sir.
Why?
Sir, it's 12.5 volts we are applying, sir. So it obviously needs some more voltage, sir,
It, it's
because
it's not 12.5. It is 12.5 minus the drop.
yes, a minus drop. Sorry, sir.
It's no, that's fine. So it's around 12 volt what you are applying. Since you want to get 12 volt, you will not get it. You will not get a regulated voltage. Now you can see here, is it regulated? Can you see this
Mm,
green is also keep changing?
yes,
How do we overcome this?
we have to
Increase the
increase the
voltage.
There is
voltage.
no other way other than going for larger rating transformer. You have to go for a larger rating transformer, meaning that the input voltage to the rectifier should be more. That is, the secondary output voltage of the transformer should be bit more. So how much it should be? So let us make it around 20. I'll make it around 20 and then run it. Just give me 1 minute time. Is it now constant?
Yes, sir.
I think it's constant. Just
Yes.
give me 1 minute. 1 minute time. Hello. ಹೇಳಿ. Okay. ಮನೆ ಹತ್ರ 1 ಗಂಟೆ 1:30ಗೆ ಬರ್ತೀರಾ? ಓಕೆ 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 ಸರಿ. Okay. Now, are you getting 12-volt constant?
Yes, sir.
Can we actually find out what is the required voltage to make it exactly 12 volt?
Yes, sir.
For that, you have to move it on the input of the regulator. How much is the voltage that it should give? Is it somewhere here? Correct?
Yes, sir.
How much is the voltage?
So 13.0.
13.
Yes,
Fine.
sir. 13.
So, if you are applying a voltage more than 13, then only you will get 12 volts. This is the exact
Okay.
value upon doing the simulation. If you apply less than that, output voltage will be not regulated.
Okay, sir.
Is
Thank
that clear?
you. Yes, sir. Thank you.
Is that clear to all of you? Any questions over here? Make it fast. Now you can see even I can remove this resistor. What I'll do, I'll remove this resistor. There is no major change. Can somebody say even if I reduce the resistor, why it's not changing? See here, in the previous case, I had a resistor. Now I have removed the resistor. Output voltage is still, it's there going up to 12 and the remaining constant. I want someone to answer. What is the role of this resistor in this part of the circuit? Even without resistor, why it is working? Make it fast.
Sir, because resistor is only. Sir,
What was the role of
resist.
resistor?
Sir, resistor is only needed in when it's discharging, sir. Means
Now,
when it's in.
now,
So due to that, I internal resistance of IC.
okay. Now, whatever the resistor which was there, which was actually providing only the discharge path for this capacitor, is that is still available in the form of the input impedance of this regulator. You can see still it is reducing. Can you see? Can you see this voltage? Can you see this is still reducing? Red one. Hello. Hello.
Yes.
Can you people still see that it is still reducing? It is reducing because there is a resistance, there is a path for your capacitor to discharge that is through this resistor, which is not seen here, but it is having some effective input impedance. It is reducing due to that. Correct? Hello.
Yes.
Now, if I remove this capacitor also, what will happen? What will happen?
It won't get load regulated.
What you will get?
Maybe only non-regulated, line regulated or straight line.
Now you can see only when the input voltage exceeds 13, it will become constant here. When the input voltage is less than 13, output will be almost following the input. Am I correct?
Yes, sir.
That's what you're getting. See this? The red one is rectified signal. The green one is what? If the input voltage exceeds 13, then it is becoming constant at 12. If the input voltage goes less than 13, it's almost following with a drop of almost 1 volt.
So regulated.
This is regulated. This is here it is
Green.
regulated. Here it is not regulated.
Yes, sir.
Correct? I just want to know from each one of you through chat box. Could you able to get all this stuff or not? Because I am not telling anything great. Nothing new here, which is already there in the earlier shared videos. Make it fast. Make it fast, and then let me do one load regulation. Okay, what I'll do, I will do undo for this F9. I'll put a resistor. Where is the resistor? I'll put R. I'll put a resistor. This is F3. We'll make the connection to that. I will I'll make this equal to 1K, and I will use this param. Where is that param? So I can go to this dot dot step EARAM or VAR. So I will change the resistance value from maybe from okay 1K to 1K to or maybe from 100 ohm to, let us just make it from 10 ohm to 100 ohm with an increment of 10. Okay, no, okay, what I'm trying to do here is, can somebody say what I'm trying to do? Hello? Can somebody say what I'm trying to do here?
Give me a random resistance value.
So getting the load regulation,
I
sir.
want to get the load regulation, for which I want to apply different resistance at the load starting from 10 ohm to 100 ohm with an increment of 10 ohm.
Yes.
Correct? I will run it now. Okay, what I'll do now is I will remove everything. If I will remove this, I will remove this also. Oh, I would have retained. Okay, let me just take only the output. Sorry, where is output? Okay, let me just see the output here. Can you see now this? Can you see what's happening? This is output voltage was supposed to be constant, no?
Yes, sir.
But you can see it's going down. It's going down here, going down here, going down here. Actually, how many such plots you are supposed to have?
Hence,
You would have
0
had
to
0 to, you would have had 0, 10, 20, 30, 40 up to 100. You would have had 10 lines, but you have only 3. The others are overlapping here. Others are overlapping. So what I'll do is I'll just do it one by one. I'll do it one by one. So I'll make it from uh, uh, maybe 70 to 100. If I run it, can you see it's almost there? They are actually overlapping.
Yes, sir.
So even if the resistance is 100 ohm, so what is that? 70 ohm, 80 ohm, 100 ohm. See here, this is actually changing from 70, 80, 90, 100. Correct? For all the resistances, even though you are drawing more and more current, the output voltage is fairly constant. Correct? Is output voltage constant here?
Yes, sir.
Even if I'm increasing the
Right.
increase the resisting from, uh, you can say for 70 ohm also it is same, for 80 also it is same, for 90 and 100. So what I'll do, I'll make it from maybe 50 to 70. Can you see 50, 70 also same?
Yes, sir.
Meaning, if it is 50 ohm, what is the current that you are drawing? It is 12 volt by 50. Correct?
Yes, sir.
I will change this
Point
to,
of view.
I'll change this to 30 to 50. Now you see.
There's a variation.
Can you see there's a reduction here?
Yes, sir.
So there is a reduction here for a resistance of 30 ohm. For a resistance of 30 ohm, so what I'll do, I'll just go back to this circuit. I'll go back to this circuit. I will not. use this. I'll make it 30 and then proceed. Can you see this happening?
Yes, sir.
This is 30 ohm resistance. Now we can see it's not a constant voltage. So there is a problem in your output voltage because you are trying to draw more current.
Yes, sir.
So this is called as load regulation. So this should never happen. This should never happen. If it is 30 ohm means what is the current that you are trying to draw?
0.4.
How come?
Sir.
Okay, 0.4 matlab because it is 12 volt by 30. Correct?
Yes, sir.
If you are trying to draw more than 400 milliamperes of current, you are in trouble. Correct?
Yes, sir.
You are in trouble. So that's what you are supposed to understand when you are actually doing the load regulation. Correct?
Yes, sir.
Okay. Shall we go for full wave rectifier? Any
Yes, sir.
doubts here? Okay. In case of full wave rectifier, what you have to do is, let me just redo the circuit here. This is F5. Okay, let me just copy this and then put it here. Let me copy this and then put this here. Okay, this is F3. Connect this to this. Connect. Is this my full wave rectifier? This is the only connection that need to be done. Am I correct? You can run it. Okay, we'll do stage by stage. We'll put a resistor. See that rectifier action. F3. I will remove this capacitor and this also. Oh, let me change the value of this to 1K. Can you see this now? Hello?
Yes, sir.
This is full wave rectifier. If I put a capacitor, what happens?
It has to drop it.
Capacitor will make it triple voltage. Correct? I will reduce the voltage to maybe around 100 microfarad. I will run it. Fine.
Yes, sir.
You can verify the ripple voltages. Let me just take out this and I will connect this regulator. Correct? Input to the regulator and then output to the regulator. Because the resistance is less here, it is being get loaded. What I'll do is I'll go to regulator and then increase the resistance. Where is that? I will make it 1K. I will run it now. Can you see now it's constant?
Yes, sir.
That's it. So this will not take, okay, how much time I took? Less than 5 minutes to migrate from half wave rectifier to full wave rectifier. So of course now I can certainly take this resistor and I can run it. You'll get the same result. Correct? Hello.
Yes, sir.
Okay. Any doubts here? Okay, let me just share this questions what I got. Is this visible now? Hello. Let me just go through the questions that are raised by you people. In a full wave rectifier, if no load were connected across the capacitor is the output voltage be constant DC voltage. So what is the answer for this, Deepika? Hello. Is the output voltage constant? Can Deepika answer this?
Yes,
Because
sir.
that's what, okay, I want people to answer, because we have shown, okay, the output voltage remains constant even if there is no load. If there is no load means, okay, output voltage is fairly constant. When both diodes are conducting, is the capacitor charged in full? No, to be very frank, both the diodes can never conduct. Both the diodes can never conduct. This diode will conduct during positive half cycle. This diode will conduct during negative half cycle. There is no question of both the diodes conducting in case of full wave rectifier using two diodes. Correct?
Yes, sir.
When both the diodes are conducting, is the capacitor charged in a full wave rectifier? No, for capacitor to charge, only one diode is enough to be conducting. If one diode is conducting, capacitor charges through that particular diode. Correct?
Yes, sir.
Okay, what is the purpose of adding a RC filter in the power supply circuit? I think this is a question put by all of you, most of you. RC filter will going to ensure that voltage to the input of the regulator never goes below the minimum voltage. Correct?
Yes, sir.
If you don't put the capacitor, then the voltage to the input of the regulator goes less than the minimum voltage, then you will not get the regulated voltage. Correct?
Yes, sir.
Okay, when the capacitor value is small, is the peak current drawn through the rectifier? No, actually, what is the value of when the value of C is less? Does the reactance offered by that capacitance is more?
Yes, sir.
Because XC is equal to 1 over the it's inversely proportional to C. No,
Yes, sir.
if the value of C is less, the amount of current flowing through the diode is actually less, because resistance offered by the capacitor is more. When the
Okay.
capacitance value is more, then the diodes have to provide more current. It's actually the reverse. If the
Okay.
capacitance value is too much, then you are in trouble of drawing too much current from the diodes.
Okay, sir.
Okay, then I'll go to next question. Okay, you may be having class now. Fine, just maybe 1 or 2 minutes. I think I have answered this. When we open LT spice, choose diodes, we get different diodes. Okay, this so and so. What does the values tell about? I think I have answered this. So they signify. Of course, you have to go to the data sheet of it and then try to find out what is the capacitance, what is the break-in voltage, what is the cut-in voltages. So all those stuff will be indicated against each of the device. This is, I think, these are Sonu buds. On what basis should we decide or dedicate the value of frequency, amplitude, and voltage? Frequency is not decided by us. Frequency for an AC signal, that too for a power supply, is always 50 hertz. In Asia and okay, other countries, except in US, where in US the frequency is 60 hertz. Correct? Is any ideal or nearby value for? No, this amplitude purely depends on what is your requirement. Suppose if your requirement is for a larger voltage, then you have to have a larger amplitude. Correct? Hello, this is whose Sonbat?
Yes, sir. Yes,
Yeah.
sir.
And are there any ICs which has all rectifiers in one? No, it is not necessary to have all rectifiers in a single one. So we have an IC with bridge rectifier. So that I'll show you someday. So there is an IC with 4 diodes in a single package, so which can be used as a bridge rectifier, and there is no such IC where it has all the rectifiers.
Thank you, sir.
Yeah, I have one more question. What happens if we use voltage regulator other than nothing will happen? So you will get the corresponding voltage. So as we are doing using LT spice, some other number. What is the LT spice number? So LT spice number is LT1085. So it doesn't matter whether you use 7805 or something else. So according to that, you will get it. Akshata, is it fine? Akshata. Okay, in which type of regulator we get efficient line regulation, load regulation? No, irrespective of the irrespective of the rectifier, when do you get good regulation is the voltage matters. You have to have an input voltage more than the required thing. So whether it is coming from half, full or bridge, it doesn't matter. So this half-wave, full-wave rectifiers will not matter for line and load regulation. As long as you're getting sufficient voltage, it is fine. Why is the discharge line in load regulation always greater than minimum voltage? Why it should be? Now, if the discharge if the input voltage to the regulator is less than minimum, then you'll not get that regulated voltage, no? Because you need to you need to allow some voltage to consume across the regulator. You are supposed to apply some voltage, otherwise you won't get a constant voltage. That's what we saw here. In load regulation, if you decrease the resistance value, will the current decrease slightly? If you reduce the resistance, current should increase, no? This can be observed. Of course, we saw there. So current actually increases if you reduce the resistance, because current and resistance are inversely proportional. If you reduce the resistance, current will increase. So it's not that okay, if you decrease the resistance, current won't increase, current won't decrease. It actually increases. Why discharging takes more time? This is done. Okay, why ripple voltage is 2 VD-on in bridge? Because why it is 2 VD-on is in the ripple expression, we have two diodes conducting simultaneously for either positive half or negative half cycle. That's why it is 2 VD-on. In case of half and bridge, it's only one diode conducting during one half cycle. That's why it is VD-on there. Now it is 2 VD-on in case of bridge. Why is RC network? Okay, RC filter is used. Okay, we know. Okay, I already answered this. Okay, with this we'll just close it. Sorry for taking another 5 minutes extra time. Please join the other class. Thank you so much.